All right, so we just finished up with factoring, and the reason why we covered factoring again is because the whole purpose of factoring is to be able to solve quadratic equations. Okay, we want to be able to solve quadratic equations. Solving linear equations is easy. You add and subtract, you multiply, divide, you've got your variables. Quadratics, you've got two variables, you've got x squared and x, so we have to use something else. So that's the whole purpose of factoring. So we're going to go straight from factoring to solving quadratic equations, and we're going to start with the first method of factoring because it's the simplest. It works in certain cases, obviously when your quadratic is factorable. But before we actually get into solving, let's talk about the possible solutions that we can have. Okay? So it's a quadratic. It's degree 2. Degree 2, we expect there to be two solutions, and the majority of the time, there are two solutions. The majority of the time, our parabolas will cross the x-axis twice. Our parabolas will cross the x-axis twice, whether they're opening up or whether they're opening downwards. A lot of times they will cross in two different places. Sometimes that's symmetric, sometimes it's not symmetric. It just depends on the makeup of the quadratic. This is the case that we call two real solutions. Okay, two real solutions. Now, a couple of different terms of vocabulary you need to know. Solutions, roots, zeros, x-intercepts, those all mean the same thing. Okay? They're just in different contexts. X-intercepts, that means you're looking at the graph and you're looking for where it crosses the x-axis. But that number is going to be the same number that's a solution to the equation. If this is crossing at 2 right here on the x-axis, then that means that x equals 2 is a solution to the equation. That will make your equation equal 0. Zeros kind of has a double meaning. It can be talking about the graph. It's where you're on the x-axis and the y equals 0. Or it also talks about where the equation equals 0. And then just roots is another word you may see out there. So you need to be familiar with those 4 terms. They all mean the same thing. If I say find the solutions, if I say find the roots, if I say find the zeros, if I say find the x-intercepts, it's all leading you to the same numbers. All right? So that's two real solutions. Sometimes it will only touch the x-axis one time. We talked about this a little bit last week, but that's the case where we have the repeated root, which happens a lot of times when we have a perfect square trinomial. So, for example, this would be x minus 4 squared. Then the solution to that equation would be positive 4. You touch the x-axis at positive 4. You don't cross. So it looks like we only have one solution, but technically we have two because it's repeated. Okay? So we've got two real solutions, we've got one real solution, and then in the case where our parabolas don't always cross the x-axis, okay, our parabolas do not always cross the x-axis, and in that situation, we have no real solutions. If it does not cross the x-axis, then there are no real solutions. That means there's no real number that if we plug it into the equation, it will give us 0. But, thanks to the lovely world of imaginary numbers, we do still have solutions. They just aren't real numbers. They're imaginary or complex. Those words are used kind of interchangeably. Complex numbers, imaginary numbers. Imaginary numbers are part of the complex number system. Okay, so if it doesn't cross, there's no real solution, but there are two imaginary or complex solutions. They come in pairs. They always come in pairs. We'll talk more about the complex / imaginary solutions later on. We won't be able to run it. We won't run into that with factoring. Okay, we will not run into that with factoring. We can only get the first two cases from factoring, but some of our other methods will lead us to those imaginary solutions. Okay? Questions about this so far? All right, so I think most of you have already done these problems, but I'm going to run through them really quickly because I want to talk about just a couple of other things about them. Number one thing that the most common thing that people forget, just like forgetting to look for a GCF with factoring, when they've got to solve a quadratic equation, they forget the fact that it has to be equal to 0. No exceptions to that. It has to be equal to 0 before you can start factoring. So if you've done that on your paper, we'll need to fix it here in a second. All right, so the first one, we don't have to worry about that. It is equal to 0, so we can just jump into factoring. Anybody remember what we call that trinomial there on number 1? When you factor it, what do you get? K minus 7 and K minus 7. What do we call them when we end up with the exact same factors? Perfect squared trinomial. I'm just going to keep bringing up that terminology until y'all remember it. Perfect squared trinomial. Okay, so it's K minus 7 times K minus 7. We set both of those equal to 0. And I know some of you can jump from there to the solutions. And if you can consistently and correctly, that is fine. But for the benefit of everyone else, I'm going to continue working it out. Okay, so we get K equals 7 for both solutions. So now you don't necessarily have to write this on your paper, but I'm just pointing it out. You technically only have to write it once, and that is that repeated root or solution of 7. Just to make sure we're all on the same page. I think I still have this one in my calculator. Yep, okay, I already have it graphed in my calculator. So there it is. There's that parabola touching the x-axis. You can see it there at 7, or you think it's at 7. You can go to the table and confirm that. When the x is 7, the y is 0. Okay? So there's several different ways that you can find these answers. Alrighty, number 2, we do have to make sure that it's equal to 0. So we've got to start by moving the 6, subtract 6 from both sides. So we've got x squared plus 6x plus 8. Again, very simple factoring here, 4 and 2. And again, some of you can skip straight from that step to the answer, and that is fine. But I'm just going to keep working it out. Subtract 4 from both sides, so we get -4 for one of our solutions and -2 for the other solution. Now, there is no reason, except laziness, and that's not a good excuse, for why, if you have an equation that you have been asked to solve, why you would not plug your answer choices back, or your answers back into the original problem to check it. I promise you, y'all make some silly, careless mistakes. And I'm not criticizing you because I make silly, careless mistakes too, but you can catch a lot of them if you'll take 2 seconds and plug it back into the original and make sure, see, I was about to make a mistake because I missed my plus sign, and make sure that the left side of the equation equals the right side of the equation. Now, this will throw some people off too. If you do not remember to put parentheses around the negative number before you square it, it's not going to work out. You're going to think you did something wrong, and you actually didn't do anything wrong. -4 is a solution, but you're just not typing it in correctly. All right, so I can do the exact same thing for number 2. Let me show you something. Some of y'all don't know this. If you press second enter, it will bring up the last thing that you typed in. So you can kind of save yourself a little bit. You can just scroll over here, and you can replace that 4 with a 2. And you can just type over it, okay? And confirm that -2, when you plug it in, also gives you +6. Okay? Make sure you plug it into the original, just in case you messed up something when you were trying to get it equal to 0. Plug it into the original. All right, number 3. Number 3, we got a little bit more work to do. Now, you have a choice. If you want to, you can move the 48m to the right side, because that would only mean moving 1 term. In my opinion, though, I don't like dealing with a negative coefficient with my quadratic, so I'm actually going to move everything to the left side, even though it means that I'm moving 2 terms. So I'm going to add 6m squared, and I'm going to add 42. So we've got positive 6m squared. Make sure you write it in standard form. Minus 48m plus 42 is equal to 0. What do we have to deal with first? GCF. All those are divisible by 6. M squared minus 8m plus 7. Now it's very simple factoring. M minus 7, M minus 1. Now, I think I talked about this a little bit last week. We set each of these equal to 0. Or maybe I'm thinking about my other class. I think I'm thinking about pre-calc. Set 6 equal to 0. Is 6 equal to 0? No, okay? 6 is not one of my solutions, but I want you to be in the habit of doing that, because if m had been a part of my GCF, if that had been a 6m in front there, then I would have a solution. 6m can equal 0 if m is 0, right? 6 times 0 is 0. So I want you to be in the habit of putting that there, even though it's not true. Write it down and then mark it out. But be in the habit in case there is a variable in your GCF. Because if you miss that, you miss one of your solutions. And that'll come into play when we get to polynomials. Okay? So 7 and 1 are our only solutions. But I did want to mention that about the GCF. Okay? Number 4, getting a little bit more complicated here. We've got some like terms on both sides. So again, moving everything to the right would mean that I'm moving less terms, but it would mean that my quadratic term ends up being negative. So I am going to move everything to the left side. Minus 5k squared. Now, you should get the same answer if you move it to the right side, if you do everything correctly. Okay, so I'm subtracting 5k squared, I'm adding 7k, and I'm subtracting 3. So 10 minus 5 is 5, so I've got 5k squared plus 7k minus 24. Let's see here, no GCF, so I'm going to go guess and check. I saw a lot of people doing slip, divide, slide, and that is absolutely fine. Let's see here, 8 and 3. 15 minus 8. Yep. Okay, 5k minus 8 times k plus 3 is how that factors. So here's why I've been writing them out. Okay, up until now, all of them have been simple one-step equations, but now all of a sudden we get this 5k minus 8 is equal to 0. That's a two-step equation. So I want to make sure we don't mess that up. Add the 8 first, and then divide by 5. So one of our answers is 8 over 5. It's not a bad thing if you don't get a whole number for all your answers. The world is not full of whole numbers. It's actually more likely that your real world answer is not going to be a whole number. Okay, so negative 3 and 8/5. I am going to check this one just to show you a couple of things. When you put in fractions, you've got to put them in parentheses. Just like negative numbers, you've got to make sure that you put parentheses around them before you square them or before you multiply them by another number. So there's the left side. The left side equals 4.6. I got to make sure that the right side equals the same thing. And it does. Left side equals 4.6, right side equals 4.6. Now I would get something different when I plug in negative 3. I just want to point that out. I don't want you to think that the answer is always supposed to be 4.6. Okay, it's going to be something different with negative 3. But it's going to be the same thing for the left side and the right side. Okay, so negative 3 gives us 69 on both sides. As long as it's the same thing on both sides, that is the correct answer. Okay? All right. One more. Number 5. 42a squared equals 9 minus 7a squared. Again, I'm going to move everything to the left side, even though it means that I'm moving a little bit more, because I don't like negative quadratic terms. So I'm going to add the 7a squared and subtract 9. So 49a squared minus 9 equals 0. What do we call that? Difference perfect squares, thank you. Okay, so difference perfect squares, 7a plus 3, 7a minus 3, automatic, all right, automatic there. So let's solve those. 7a plus 3 equal to 0, 7a minus 3 equal to 0, subtract 3, divide by 7, a equals negative 3 over 7. Add 3 for the other one, 7a equals positive 3, divide by 7. Our other solution is positive 3 over 7. Here's the neat thing about the difference perfect squares. Their answers always come in pairs. You're going to get the positive and the negative of some particular number with the difference perfect squares. They're symmetric about the y-axis. Okay, let's look at this one really quickly just so I can point that out to you. We got to put in the solved version, 489x squared minus 9. Okay, it's very, very skinny because that 49 makes the parabola very, very skinny. But you can kind of see how it's symmetric here about the y-axis. It crosses the x-axis in the same place on the positive side as well on the negative side. Okay? So a lot of times, I'm not going to require that you write the answer with plus or minus, but I do want you to be familiar with that notation because you will, I write it like that, you may see it like that on like a final exam or something. Okay? All right, so